Hello students, welcome to Boundless Maths, where we make maths not just understandable but also enjoyable. In today's video, we are going to cover indefinite integrals as part of class 12 maths curriculum. Indefinite integrals form the basis for definite integrals and even applications of integrals that we are going to cover in subsequent videos. If you have a strong foundation for indefinite integrals, you will not face any kind of problems doing applications of integrals. So let's get started with indefinite integrals. Now in this video we are going to cover indefinite integrals. So overall in integral calculus we have primitive integration or finding the antiderivative of a function. Then we have indefinite integrals, definite integrals and then applications. So this part, indefinite integrals, this actually forms the basis of doing definite integrals and applications. If you are clear with this part, you will not face any problem going further and doing applications of integrals. So let's start with what is integration. What is integration? We have already done differentiation in grade 11 also and in 12 also. We understand what is differentiation. For example, if there is a function x square and when we differentiate it we get 2x. Now 2x is fine, but when we integrate is the opposite of differentiate. So when we integrate 2x we get x square plus a constant, because even if we have a function like x square plus 1, the derivative is 2x. X square minus 2, the derivative is again 2x. So there are infinite such functions whose derivative is 2x, and when we do the reverse operation, that is integration, this constant of integration becomes very important, because this constant may be 0, this constant may be a positive numeral or a negative numeral or anything. So you need to take care that you are always adding the constant of integration when we talk about indefinite integrals. Right? So the primitive integral functions, the basic integral functions are here. The first one is integral of x to the power n is x to the power n plus 1 upon n plus 1 plus constant of integration c. Second one is integral of 1. Integral of a constant is x plus c. Integral of 1 by x is log x plus c. So it is entirely the opposite of what you have done in differentiation. The next one is integral of e raised to power x is e raised to power x plus c. A raised to power x integral is a raised to power x upon log a plus c. And then 1 by square root x. Now if you look at these functions, they are all derived from the basic function, that is x to the power n. So if you understand x to the power n, if you can remember this, x to the power n plus 1 upon n plus 1. So this is x to the power minus half. Minus half plus 1 becomes half, and the denominator half goes to the numerator, so it becomes 2 square root x plus c. As you do practice of these questions, you will anyhow remember these integration formulas, the primitive integrations. It's always good that you remember them so that you save your time while you are solving questions. 1 upon x to the power n is actually x to the power minus n, so it is minus 1 upon n minus 1 x to the power n minus 1 plus c, right? Now there are few properties, basic properties of integrals that we are going to use in almost every function. The derivative of integral of a function is the function itself. So it is basically integral of a function, and when you differentiate you get the function back. So basically you can understand it like this, that the derivative and integral, they cancel each other, they cancels, and you get the function. Integral of a derivative gives you a function along with the constant of integration. So even if derivative and integral are cancelling each other, you are getting the function back, but now it is with the constant of integration. So again I am emphasizing, please remember this constant of integration is very important when we are doing indefinite integrals. Next property is when you have multiple terms of an expression or multiple functions being added or subtracted and you need to integrate the entire function, then it is the integration of individual functions, right? And if you have a constant along with a function, you can just move this constant out and then integrate the function with the variable, okay? Now this is very important. When you are integrating integral of fx dx, the integral is capital Fx, right, plus c. So if you replace this x with a linear function of x, ax plus b, remember it is only linear function of x, ax plus b, that means you multiply this by a constant and then add another constant, then the integral becomes whatever was the integral before this, f of ax plus b upon a. So you have to divide by the coefficient of a when x has been replaced by a linear function of x, linear polynomial of x. Okay. Now there are few properties of log also that might be useful when you are doing these questions. The first one is p log x equals log of x to the power p. So this p goes as an exponent to x and it comes to the right side. Next property of log that might be helpful is e raised to power log x just gives you x. When there is nothing between e and log, these two words, e and log, there is nothing between them. This p has gone to the other side as an exponent and there is nothing between e and log. They cancel the effect of each other and eventually you just get x, right? Next is a to the power log of x to the base a. Now again the base of logarithm and this a is same, then again you get x. So these properties might be helpful when you are doing certain questions on integration. So let's have a look at some practice questions. The first question is integral of x square plus 1 into x minus 2, right? So in the basic initial level questions, what you need to do is just simplify the expression and get different terms, separate it into different terms. So let's do that. We'll use distributive property and just simplify this polynomial. So x square into x becomes x cube minus 2x square plus x minus 2. Now you need to integrate this. As per the formula for integration, we can easily integrate this expression and we get x to the power 4 upon 4 minus 2 x square becomes x to the power 3 upon 3 because the power gets increased plus x becomes x square and minus 2 becomes minus 2x, and please do not forget the constant of integration. So this is the answer for this question. Easy? Next question, ax plus b whole square. Now you can use the formula for x to the power n also here and you can just expand it using a plus b whole square and then integrate the individual terms. So let's use the identity and then integrate. Ax plus b whole square becomes a square x square plus b square plus 2abx, and then you need to integrate each term individually. So you will get, now a square is the constant, so you can write the constants as it is. Integrate x square is x cube upon 3. B square is a constant, so you write b square as it is and then you get x. 2ab is again the constant, so it is 2ab, and integral of x is x square upon 2 plus constant. So this 2 gets cancelled. Eventually what do we get? A square upon 3 x cube plus, let's write them in the order of decreasing power of x square, and then you have b square x plus c. So this is your answer. Easy? Next is integral of e to the power 2 log x to the power minus 3 dx. How do we integrate this? Now here we need to use the property of log. So this 2 goes as a exponent to this x. So this becomes e raised to power log of x square multiplied by x to the power minus 3 dx. Now this e and log, they get cancelled and you get only x square here. So it becomes x square x to the power minus 3 dx. Using the laws of exponents, when you add them, it becomes x to the power minus 1 dx. So basically it is 1 by x dx. The integral of 1 by x is log x. So the answer is log x plus c. Easy? Okay, let's come to the next one. Now here we need to find the integral of 3x plus 5 under the root. The entire expression is under the root. That means 3x plus 5 raised to the power 1 by 2 dx. I can write it like this? Yes? Okay. Now this is n. So it becomes what? X to the power n becomes x to the power n plus 1 upon n plus 1. So it is x to the power of n plus 1 upon, what is half plus 1? Half plus 1 is 3 by 2 divided by 3 by 2 plus c. So when you inverse this, it becomes 2 by 3 of 3x plus 5 to the power of 3 by 2 plus the constant of integration. So this is your integral. Easy. Next question again uses properties of log. So it is log x here, and it is log x. So this is the complete function. So let's use the properties of log again. So this 6 will go as an exponent, and this 4 will also go as an exponent, 5 will also go there, and this 3 will also go there. So then how do we solve this? Integral of e raised to power log of x to the power 6 minus e raised to power log of x to the power 5 upon e raised to power log of x to the power 4 minus e raised to power log of x cube. So this is what you need to integrate. We have used the property of logs. Next, e and log, they will cancel each other, and what you will get is integral of x to the power 6 minus x to the power 5 upon x to the power 4 minus x cube dx. Now you can take out common from both the terms. So it becomes x to the power 5, and in the bracket you have x minus 1 left out. In the denominator you have x cube and x minus 1. So here x minus 1 gets cancelled, and we have eventually x to the power 5 upon x cube. So this becomes integral of x to the power 5 minus 3 is square. Now this is extremely easy. You can just write x cube upon 3 plus the constant of integration. So this becomes your answer. So these were some very basic questions that use the primitive formula for just doing integration. Now let's understand the integral of rational polynomials. So what are rational polynomials? Like we have rational numbers, we have rational polynomials where we have a function in the numerator and a function in the denominator, right? Now when we have two functions written in this form in the question, you need to, first thing is you need to understand that the degree of the numerator has to be less than the degree of the denominator for integrating it. Then it becomes, you can use partial fractions or integration by parts or anything, whatever you are using, but before that the degree of numerator has to be less than the degree of denominator. So how do we take care of that? If the degree of the numerator is greater than or equal to the degree of denominator, how do we convert it to a proper rational function? So this is a proper rational function, and if the degree is equal to or greater, then it is improper. So the first way is, if the denominator has only one term, you just separate out individual terms and then integrate. We'll do some examples, you'll understand it better. So the different ways are, the first is if the denominator has only one term, you just separate out all the terms and then integrate them, right? Second is you factorize the numerator. Somehow if you can factorize this and the denominator, and you can cancel some of the factors, so that will make your work easier, right? Now suppose this is not factorizable and you are not able to factorize it easily, then there is something called balancing. We'll understand what is balancing when we do a few questions. And the last method that could be used is long division. Basically the way you convert an improper fraction to a proper fraction. How do we do that? Improper fraction, numerator upon denominator. If the numerator is more than denominator, you divide the numerator by denominator, you get some quotient and you are left out with some remainder. This is how you do conversion. So it is Q, R and D. Now this is how you convert an improper fraction to a proper fraction. So we'll apply the same logic here for polynomial functions, right? So you can convert an improper rational polynomial to a proper rational polynomial by doing long division. And there are shortcuts, Vedic math shortcuts also, that make you do this division faster, that we are going to cover in the subsequent questions. So let's get started with rational polynomials, integral of rational polynomials. Now here the denominator has only one term. Remember, when the denominator has only one term, it is very easy to separate out all the terms. So this becomes integral of a x square upon square root x plus b x upon square root x plus c upon square root x. Now we need to integrate this function, right? We can just club the powers of x. So this becomes integral of a 2 minus half. How much is 2 minus half? 2 minus 1 by 2 is 3 by 2. So we have x to the power of 3 by 2 here plus b 1 minus half. 1 minus half is half. So it is x to the power half plus c x to the power minus half because it is in the denominator. We need to integrate this function now. Please don't remember to write this dx here and put brackets around the entire integral function. This means the entire function is being integrated with respect to dx, right? Okay. Now it is easy to integrate the individual terms here. So this becomes a x to the power 3 by 2 plus 1 is 5 by 2. So the exponent becomes 5 by 2 and you have 2 by 5 on this side. Plus half plus 1 becomes 3 by 2. So you will have 2 by 3. B will remain as it is, x to the power 3 by 2. Next, c to the power minus c x to the power minus half. So it is x. So it is going to be c as it is and x to the power minus half. Minus half plus 1 is half. So it is going to be square root of x and 2 comes here. Half, when you inverse 2, it becomes 2 by 1, right? Now the constant of integration, please do not use c because c is already being used here. So you can use the alphabet k or you can use capital C for the constant of integration. So avoid using the same literals. If c is already used in the question, don't use c, use something else. Either you use c dash or you use capital C or you use k or something else, right? Done. Now the next method is factorization. If you look at this question, in the numerator we can use the identity for a cube plus b cube. So how do we factorize that? What is the identity? A cube plus b cube is equal to a plus b and then a square minus ab plus b square. This you have done in lower grades. So let's factorize the numerator. It becomes x plus a into x square minus ax plus a square and this whole upon x plus a and the derivative dx. So now x plus a gets cancelled and you get a polynomial with 3 terms which can be integrated very easily. So it is integral of x square minus ax plus a square dx. Now we can integrate the individual terms easily. Integral of x square is x cube upon 3 minus a x square upon 2 plus this is going to be a square. A square is the constant. So we will just put the variable x, a square x plus constant of integration. So this is the answer, right? Let's come to the next question. X cube plus x square plus x plus 1 upon x plus 1. Now in this question the degree of numerator is greater than the degree of denominator. So what we should do is, we cannot factorize it easily, but if you put the value of x as minus 1 into this numerator, you can make out that minus 1 is a factor. So that way you can factorize, right? So if you put x as minus 1, it becomes minus 1 cubed minus 1 plus 1 minus 1 plus 1, so it becomes 0. That means x plus 1 is a factor of this polynomial. So once you have figured out the first factor, you can do either long division or you can apply the Vedic maths technique to find the second factor of the numerator. So how do we do long division? You must have done this also in lower grades. X cube plus x square plus x plus 1. How do we divide this by x plus 1? In the rough space, x cube divided by x gives you x square. So the first term in the quotient is going to be x square. Now x into x square becomes x cube. 1 into x square becomes x square. And then you change the sign, both these terms get cancelled, bring down x plus 1. So this is same as this, that means x square plus 1 gives you x plus 1, and when you change the sign, both the terms get cancelled and you get 0 as remainder. So that means the remainder is 0. The numerator can be entirely factorized into 2 factors, that is x plus 1 and x square plus 1. And the denominator is x plus 1. Now you need to integrate this with respect to x. X plus 1 gets cancelled and you are left out with only x square plus 1 dx. Again these brackets and dx is very important when you are doing integration. So the integral of this is x cube upon 3 plus x plus the constant of integration. So this becomes your answer, right? So far I guess it's very easy. Now the next question, x upon 2x minus 3. Here the degree of numerator is exactly same as the degree of denominator. So again you need to reduce the degree of numerator. How you can do that? Now neither of them can be factorized, right? Nothing can be factorized or cancelled, and division of numerator by denominator also looks a little difficult because it is only x in the numerator. So what you do is something called balancing. What is balancing? Somehow we try to make this numerator look like or approach the denominator somehow, make it equal to the denominator. How do we do that? Now if I multiply and divide this expression by 2, will that matter? Nothing. It's okay. We can introduce constants like this. Only constants, remember, you can multiply, divide by only constants. Don't use variables for that. Next, now we have 2x in the numerator, but the denominator has 2x minus 3. So what I can do is, half is outside, I can do minus 3 plus 3. It is not going to impact the numerator at all. And now my denominator is 2x minus 3 and we have dx here. Now we have something similar to the denominator in the numerator also. So you can separate out both the terms like this. This is one fraction and this is the other fraction. So the integral becomes half, and then you have 1 plus 3 upon 2x minus 3. Put the brackets and then write dx. Right? Understood? Easy? So now you can integrate this expression very easy. You already have half outside, keep it out. Integral of 1 is x plus constant, you write the constant first. Now what is integral of 1 by x? It is log x. So that means integral of 2x minus 3 is going to be what? What will be the integral of 2x minus 3? It is going to be log of 2x minus 3. Again, there was one property, if the coefficient of x, if x has been replaced by a linear polynomial of x, the coefficient of x comes in the denominator. So here the coefficient of x is 2, so 2 will come in the denominator also, and then we have the constant of integration. Also remember, the argument for log is always positive, so you should use absolute value sign here. Now this becomes what? You take this 2 out, so it becomes 1 by 4. And in the brackets you have 2x plus 3 log of 2x minus 3 plus the constant of integration. So this becomes your answer. Understood what is balancing? Balancing means somehow you manipulate the numerator and make it similar to the denominator so that you can separate out the terms of numerator and get something that you can integrate easily using the basic formulas, right? Now the next question, x square plus 2 upon x plus 1. How do we integrate this? Degree of numerator is more than the degree of denominator. So that means you can do factorization, but factorization not possible here. Balancing, not possible because the degree is greater, not equal. If it was equal, then you could have done balancing. But now the degree is greater than the denominator. So you are left out with only one option, that is long division. So let's do long division and then we'll see how to do it using Vedic maths also in a faster way. X square plus 2 and this is x plus 1. So when you do division, this is x, so it is x square plus x. Now this minus, this gets cancelled and we have x plus 2 left out. And now we use plus 1 and we get x plus 1. Change the sign and you get 1 as remainder, right? How do we use it? This is x square plus 2 upon x plus 1. So we got the quotient as, okay, I made a mistake here. You need to change the sign of these terms when they are being subtracted. So it is minus x here, so it should actually be x minus 1 here. And when you do this, the sign again gets changed. And you get the final answer, final remainder as, so the remainder is, this gets cancelled and the remainder is, plus 3, not 1. So the remainder is 3, right? Now in Vedic maths there is a shortcut to do this division, 1, 0 and 2. You write the coefficients of decreasing powers of x. X square, coefficient of x square is 1, coefficient of x is 0 here and the constant is 2. You make this division sign, write 1 here, you start with 1, minus 1 because the factor is x plus 1. So you write minus 1 here, bring down this 1, multiply 1 by minus 1, it becomes minus 1. 0 and minus 1 is minus 1, multiply minus 1 and minus 1, it becomes plus 1. And 2 plus 1 gives you 3. 3 is the remainder, what you got here. And how do you convert this into a polynomial is, the degree of this expression was x cube, so you start with 1 degree lower, it becomes x square, and it was x cube, no, it was x square. So the degree of this polynomial was x square. So that means you get an expression that is 1 degree lower, so you will get x and then minus 1. So this was what we got as quotient also, right? So you can use either technique and just factor and just divide this numerator by the denominator. So what do we get? How do we write the mixed fraction? Quotient by the side, remainder upon divisor. So we'll write the quotient by the side, that is x minus 1, and then remainder in the numerator, and then x plus 1, which was what was the divisor. Put this entire expression into a bracket and then write dx. Don't forget this dx and the brackets. Now you need to integrate each term individually. Integral of x is log x. Integral of 1 is x. Sorry, integral of x is x square by 2, not log x. Integral of x is x square by 2. Integral of 1 is x. And then 3 is the constant. Integral of x plus 1 is log of x plus 1. And then you have the constant of integration. So this is your final answer. Understood? So the main thing here is when the degree of numerator is more than the degree of denominator, use long division, use Vedic maths technique, factorize it, write it in the form of proper fraction. Whole part here and the proper fraction here, and then you can use log here, right? Now let's come to the last question of these rational expressions. If you have something under the radical sign, two terms being added or subtracted, we always do rationalization, right? It could be rationalization of the numerator also or the denominator, either could be in that form. So here we need to rationalize the denominator. How do we do that? X plus 4 minus square root of x minus 3 multiplied by x plus 4 plus square root of x plus 3 upon x plus 4 and then plus square root of x plus 3. So this is what you need to integrate now, right? Now the numerator is easy. Numerator is just the expression this. What is there in the denominator? A square minus b square. So a square is x plus 4 and b square is x minus 3. So it is minus outside. I'll just remove the brackets. It becomes minus x plus 3 integral of the entire expression, and then this x gets cancelled. So the denominator is now a constant 4 plus 3, which is 7. So I can take this 7 out and I can write 1 by 7 integral of square root of x plus 4 plus square root of x plus 3. Put brackets around multiple terms and then write dx also. Now 1 by 7 integral of x plus 4 to the power half. Half becomes 3 by 2. So you will write x plus 4 to the power of 3 by 2, and inverse of 3 by 2, 2 by 3 comes here. 1 by 7 is outside, so let's keep 1 by 7 outside only, right? Plus x plus 3, the exponent again 1 by half, 1 by 2 becomes 3 by 2, and you have 2 by 3 here. And the constant of integration. 2 by 3 you can take common out. 1 by 7 into 2 by 3 becomes 2 by 21, and you have x plus 4 to the power 3 by 2 plus x plus 3 to the power 3 by 2 plus the constant of integration. This is your final answer. Understood? So when you have a rational expression with something that you can rationalize in the form that you can rationalize, just rationalize it. The denominator becomes simpler, and then you can integrate individual terms, right? Now the next, what do we have next is some special standard integrals. Now you need to learn these formula and look at the question carefully. If it is of any of these forms, then you just apply these formulas, right? How do we learn them is a challenge. Let's look at each of them and see how do we learn them. 1 upon x square minus a square. When you have x square first, you write 1 by 2a log of absolute value of x minus a upon x plus a. So how do you learn that? It is x minus a. X is coming first. So this entire thing goes in the numerator with the minus sign, x minus a, and x plus a comes to the denominator. 1 by 2a is outside. In the next formula, what do you have? A square minus x square. Just their position has changed. When it is the constant initially, then a minus x stays in the denominator and you have a plus x in the numerator. So first learn these two formula. 1 upon x square minus a square is 1 by 2a log of x minus a goes up. X minus a upon x plus a. When you have to integrate 1 upon a square minus x square, then again it is similar, 1 by 2a, and a square minus x square brings a minus x in the denominator, a plus x in the numerator. Learned? Learned these two? Perfect. Now let's come to the next two. What is happening here is 1 upon square root of x square plus a square. In the first two, we don't have any formula for a plus in between x square and a square because that involves trigonometric functions. So we are not using this here. So we just have x square minus a square and a square minus x square, nothing like x square plus a square. So you will not have a question with that pattern, x square plus a square, because it involves trigonometric functions, right? So now 1 upon square root of x square plus a square. Here you have x square plus a square, x square minus a square. How do we learn this now? This is log of x plus the entire radical sign expression as it is. So it is log of x plus whatever is under the under root sign, you write that as it is here, plus c. Again 1 upon square root of x square minus a square means log of x plus the entire expression here plus c. Easy to learn? Again I will repeat the first four ones. 1 upon x square minus a square is 1 by 2a log of, because it is starting with x, so x minus a goes up. You just need to take care of this plus and minus sign here. This is very important. When it is starting with x, x square minus a square, x minus a in the numerator, x plus a down. When it is starting with the constant, a plus x up and a minus x down. When it is square root, the denominator is under the root, then you have to use log. Log of x plus whatever is under the radical sign as it is, log of x plus whatever is there as it is, right? The first four done. Let's look at fifth and sixth. Now here the entire expression that was in the denominator in third and fourth, we have it in the numerator. Move it up, right? Now everything is in the numerator. How do you integrate this? Half of x square root of x square plus a square. The entire radical sign as it is comes here. Half of a square log of x plus square root of x square plus a square. Next, x square minus a square, you have half of x square root of x square minus a square minus half of a square log of x minus square root. Now entire ये जो log वाला था, log, the log वाला expression comes as it is here, and you have half of square root x square plus a square as the first term, right? Now if you look at these, all these formulas, standard formulas, these are standard integral formulas that you need to use in the questions directly looking at the pattern of the question. If it is following any of these patterns, you have to use the formula directly. Here in 1, 2, 5 and 6, if you look, the integral has a also, a square, 2a, 2a. That means when you are applying these formula, make sure that the coefficient of x is 1 here. The coefficient of x should be 1, only then you use these formulas so that you get the correct value of a when you are integrating. Next thing you need to take care is when you have square root. Here you could convert it into the form of x square plus a square first. So here method of completing the squares would be useful, which you might have done in lower grades. If you have not done, we'll just do a short recap of what is the method of completing the squares and how do we use it here in integration. So these are some standard formula which you need to learn and you need to apply them directly when you are doing integration. Now let's look at this question, integral of 1 upon square root of 9 plus 4x square. So this integrand is similar to the form of formula number 3. So I'll write this as 1 upon, this is 3 square plus 2x square, and this under the radical sign, integral of this. Now how do I apply this formula? Look at formula number 3. The integral of this is going to be directly log of x. X was this x. So it is 2x here, so you will write 2x. Log of 2x plus whatever was under the radical sign, no need to write it in this form, just write whatever was there in the question. So it is 9 plus 4x square, and that's it, add c. So this is the integral of this question. Easy. So you need to remember the formula and just apply as it is, right? Now in the next question we will see how to apply the method of completing the squares before you apply the formula for any of these patterns. Here in this question you have a quadratic polynomial under the radical sign in the denominator. Now here you cannot apply any of these formulas directly. So what you need to do is, you will first convert this into the form of x square plus a square. How do we do that? Now we know the first identity, a plus b whole square. What is a plus b whole square? A plus b whole square is a square plus b square plus 2ab. Here you have the square term x square and you have 4x. This is in place of 2ab. So it is 4x is 2 into, one of the terms is x. There is no coefficient. So 2 into x into dash. You need to identify what is b here. So 2 into x into dash makes it 4x. That means the value of this b here is 2. So that means I need, apart from x square, I need 2 square, that is 4 also. So to this entire expression you are going to add 4 and subtract 4. Something like balancing again. So it is not going to impact if you add or subtract 4 here. So it becomes 5 plus, I'll just shuffle the terms. So I'll start from the x square term. So it is going to be x square plus 4x plus 4 minus 4, and then this constant 5 is also there. Now you can write x square plus 4x plus 4 can be written as x plus 2 whole square. Yes. So this becomes 1 upon square root of x plus 2 whole square, and what is minus 4 plus 5? 1. So I can write this as 1 square. Now it is in the standard form what we have seen above, 1 upon square root of x square plus a square. So what is the formula? When you have square root in the denominator, the formula is involving only one expression of log. So that is what? Log of x plus whatever is under the radical sign, write it like that only. So it is going to be log of x. What is x here? X plus 2. So you will write x plus 2 plus the entire expression under the radical sign. This is going to be the same as this. So you can directly write whatever was given to you in the question. You can just write that directly here. So it is square root of 5 plus 4x plus x square. The entire radical sign expression as it is, and then plus the constant of integration. So this is the answer for this question. So method of completing the squares helps you to transform the quadratic polynomial under the radical sign into the form of x square plus a square. So you have to look at it very carefully. X square is already there. This is actually 2ab. So what is b? Same, add and subtract the same b, whatever, square of b. And club the constants together and entire expression for a plus b whole square, you get that, right? So it becomes a plus b whole square and then constant ka square, right? So you can directly apply the formula. Next is, now there are few methods of doing indefinite integrals apart from these primitive and standard formulas or rational expressions. So this was something very basic where you had some polynomial or a rational polynomial, or you had some standard integrals that you could easily convert to their integral form, right? Now we have something called methods of indefinite integrals. There are 3 methods. The first one is substitution, next is partial fraction, and next is by parts. Which one to use when? It is very important to identify. Whenever you have a question on integration, first look at the question, is it matching with the standard formula anywhere? Use it directly. If it is not matching with any of the standard formulas, think which method is appropriate. If you can substitute a function, we'll see what function, how to substitute. Substitute a function, replace it with another variable. If you can use partial fractions, use that. If you can use by parts, use that. So we'll look at each of them in detail, how to use and what to use when. First one is integration by substitution. Now here substitution means you substitute one expression with a new variable. For example, x square plus 2, let x square plus 2 equal to t, and then you simplify the original expression and then solve it. So it is very important that you select proper function for substitution. So you need to identify it properly. Identify the function whose derivative is given in the question. So if you have something like 2x is there in the question and you also have x square somehow, then you put x square, the function involving x square, as substitute that for another variable t. So you have to look at the question carefully, which function has its derivative also somewhere in the numerator, denominator, or somewhere besides it. So whichever function has its derivative, put that equal to t, right? Next is if the exponent of the function is a fraction. For example, you have a function with, what is the exponent here? 1 by 2. What is the exponent here? M by n. So if it is 1 by 2, you can directly put whatever is under the radical sign, put that equal to t. Or you can also put it as equal to t square in this case, because it was square root. Now if the exponent is a fraction, m by n, you can put the function under this exponent, fractional exponent, whatever function is there, you can put that fraction as t to the power n. T to the power n. N is the denominator of this fraction. So it is t to the power n. Next, functions that involve log x or e raised to power x. If this x, argument of x, or the exponent of e, this is replaced by some other function gx, then you put that gx as t. So if you have something like log of ax plus b in the question, so you will put ax plus b as t and then try to solve it, right? And if you have e raised to power ax plus b, then again you will put ax plus b as t and then try to solve it. For nested functions, if you have nested functions, one function and there is another function inside it, then the inner function has to be substituted for the next variable t. So you have to first select proper function that you need to substitute for another variable t and then do it. Now there are two shortcuts here, two properties that are very useful when you are doing integration. Fx to the power n, and this is derivative. When you have a function to the power of something and the derivative of the function is besides it, you have the derivative just besides it. This exponent, just ignore this exponent, derivative of only the functional part is being multiplied here. Then what is the integral? The integral is the entire function, integral of only this function, fx to the power n plus 1 upon n plus 1 plus c. This is one property, it is a shortcut using all these substitutions you will come to. Second is, if the numerator is an exact derivative of the denominator, it is exact derivative. In the first property, this is not exact derivative. You just ignore this n and then see if this is derivative of fx. But in the second property, the numerator has to be an exact derivative of the denominator, including any exponents if at all are there. Then the integral of this function is going to be log of fx. The way we do 1 upon x is log of x. So f dash x upon fx, if you have a function of this form, you directly write the answer as log of fx plus c. So these are two special shortcuts that are going to be handy when you are dealing with questions where you can substitute, where you need to substitute one expression or one function and then solve it. Now let's look at some examples. Integral of x into square root of x plus 2. So whatever is under the radical sign, put it as t. So if you put x plus 2 as t and now you differentiate this, it becomes dx, derivative of 2 is 0. So dx is equal to dt. So that means now in this question I can put x plus 2 as t. So there is t under the radical sign. Dx can be replaced by dt. Now what do I do with this x? We have used x plus 2 equals to t. This also means x can be written as t minus 2. So I will replace this x by t minus 2. Now it is in a form which you can easily integrate. Just open the bracket and integrate the individual terms. T into square root of t dt minus 2 integral of square root of t dt. Right? I have just opened this bracket. What is the power of t here? It is integral of t to the power 1 and half. 1 and half is 3 by 2. So it is t to the power 3 by 2 dt minus 2 integral of t to the power 1 by 2 dt. Now how do you integrate this? T to the power 3 by 2 becomes t to the power of 5 by 2 and you have 2 by 5 by the side. Minus 2 t to the power half. Half plus 1 is 3 by 2. So it becomes t to the power 3 by 2 and you have 2 by 3 by the side plus the constant of integration. So the answer becomes 2 by 5. In the answer you should not leave it in the form of t. You have to replace t with x plus 2 back because the question had x not t. So it is going to be 2 by 5 x plus 2 to the power of 5 by 2 minus 4 by 3 x plus 2 to the power of 3 by 2 plus the constant of integration. So this is your final answer. Clear? So you have to select which function can be substituted for t and then replace it in the original function and integrate it. Right? Now in this question, because it was under the radical sign x plus 2, so this could have been used as x plus 2 equal to t square also. You could have substituted it as t square also, but you will get the same answer. So it's up to you. If you are in the habit of in the radical sign you have a function, just put it as t and then just simplify it. Next question is 2x upon cube root of x square plus 1. Now here you have something under the radical sign and the power is 3 by 2. Right? So whatever is under the radical sign, put it as t. So it is going to be x square plus 1 equals t. So this makes it 2x dx equals to dt. So in the numerator we have 2x dx. So I will replace it by dt and the denominator becomes cube root of t. So this t has an exponent of minus 1 by 3. T to the power minus 1 by 3 dt. And when we integrate minus 1 by 3 plus 1 becomes 2 by 3. So it is t to the power 2 by 3 and 3 by 2 by the side plus constant of integration. In the final answer again replace t back with the original function. So it is 3 by 2 x square plus 1 to the power 2 by 3 plus c. So this is the final answer. Understood? Wonderful. Let's look at another example. It is 3 to the power 3x into 3 to the power x dx. Now here because 3 to the power x is in the exponent form also, power of 3, base is 3, 3 to the power 3x. So you can put 3 to the power x as t. Now how does it work? How do you differentiate 3 to the power x? What is the derivative of 3 to the power x? Yes, it is 3 to the power x log x. So it is 3 to the power x log 3 dx equals dt. Now in the numerator we already have 3 to the power x dx. Yes, so that means 3 to the power x dx can be replaced by 1 upon log 3 and we have dt here. So this becomes 3 to the power t and 3 to the power x dx is to be replaced by 1 by log of 3 and dt here. 1 by log 3 is a constant, so I can bring it out. So I can make it here 1 by log 3 and I need to integrate 3 to the power t dt. What is integral of a to the power x? It is a to the power x upon log a. So that means it is going to be 1 upon log 3 plus, not plus, it is multiplied because this is just outside. Integral of 3 to the power t is 3 to the power t upon log of 3 plus the constant. So this actually becomes 3 to the power t upon log 3 whole square plus the constant of integration. So this is your final answer. No, not the final answer, because you need to replace t by the original expression in x. So this becomes 3 to the power x upon log 3 whole square plus c. So that means this is your answer eventually. Hope you understood. The next question, e raised to power x 1 plus x upon 1 plus x e raised to power x whole square. Now in this question again you can put the denominator equal to t and then just simplify it. So if I put 1 plus x e raised to power x, so I am going to put 1 plus x e raised to power x as t. Differentiate this using the product rule. First function into derivative of second plus second function into derivative of first, and then dx equals dt. That means if I take e raised to power x common out, it is going to be x plus 1 and then dx equals dt. Now in the question I have the exact numerator e raised to power x 1 plus x into dx, so I can replace it with the dt, and in the denominator now I have t square. So this is my question now, which is easy to do. T raised to power minus 2, what is integral of t raised to power minus 2? Integral of t raised to power minus 2, what is it? So it is going to be minus t raised to power minus 2 plus 1 is minus 1, so it is minus 1 upon t plus c. Again I need to replace this t with, it becomes minus 1 upon 1 plus x e raised to power x plus c. So this is my final answer. Easy? Let's look at the next question. 2x minus 3 upon x square minus 3x minus 18. Now here if you look at the pattern of the question, the numerator is exact derivative of the denominator. 2x minus 3 is exact derivative of x square minus 3x minus 18, 2x minus 3. So that means it is of the form where you have the derivative in the numerator and the function is in the denominator. So this integral of this is log of fx plus c, right? So that means you can directly write this as log of x square minus 3x minus 18 plus c. This is a special form of substitution. Actually you get this formula by doing substitution only. If you substitute the denominator as t and then do it, so this is just a shortcut, you just do it in one step rather than following the entire process, right? Next look at the next question. A to the power x minus 1 log a plus x to the power a minus 1 upon a raised to power x plus x raised to power a. Now here again put the denominator as equal to t. So we will do put a to the power x plus x to the power a as t. Differentiate this, what do you get? So it is going to be a to the power x log a plus a x to the power a minus 1. Put it in under brackets, dx equals dt. Look at the question, pattern of the question now. With log a you have a to the power x minus 1 and the exponent for x is a minus 1. So what you do is, if you take a common out, it becomes a to the power x minus 1 log a plus a has gone out, so it is x to the power a minus 1 here, dx equals dt. Right? So that means I can write this entire expression as 1 upon a dt. So this numerator can be written as 1 upon a, I will keep it out, and this can be replaced with dt upon, I have put this as t, so it is just t. So integral of 1 by t is log of t. So this becomes 1 by a log of t plus c. Now replace this t with the expression again, the function, original function. So it is log of a to the power x plus x to the power a plus c. So this is my answer. It is A, not 9. Right? Easy? So you just have to understand what you need to substitute. Normally whatever is under the radical sign, or normally the denominators or arguments of logs or exponents for e, so all those functions are put as t, and then you can simplify the question. Now the second type of indefinite integral, the second process or the second way of doing it is partial fractions. Where do we use partial fractions? We use partial fractions where the denominator can be factorized easily into linear polynomials, or at most there can be one quadratic polynomial. So these partial fractions, I hope you are clear with the entire process of partial fractions, how we used to do that. The denominators are written, and they are written, the entire expression is written in the form of partial fractions. Partial means part of. The entire fraction is written in the form of parts. So these are partial fractions which are equivalent to the original fraction given in the question. You separate them as a upon x minus a, b upon x minus b, and then when you do take the LCM and compare the coefficients of x square, x and the constant term on the left and right side, you get the values of a and b. Once you get the values of these constants, capital A, capital B, you can integrate them directly the way we have done so many questions so far, right? So we'll just have a quick look at some of the questions that can be done using partial fractions. So the pattern to recognize is that the denominator is either already given in the factorized form, or you can easily factorize into linear factors. For example, the question is this: the denominator is already in the factorized form. So what you are going to do is, let 1 upon x minus 1 into x plus 3 be equal to a upon x minus 1 plus b upon x plus 3. Now you need to, intention is find the value of capital A and B. Find the value of A and B so that this integrand can be written in the form of two simpler fractions which can be integrated easily. Now when you put this as equal to a upon x minus 1, b upon x plus 3, look at the coefficients of x, x square in the numerator. So if I take LCM of this, it becomes a into x plus 3 plus b into x minus 1, and here the numerator was just 1. So you need to equate the numerators because the denominators anyways would become equal when you take the LCM of the right side. Now when you look at the left side, there is no term for x, that means coefficient of x is 0. On the right side, what is the coefficient of x? A and b. So that means a plus b is going to be 0. Look at the constant terms. On the left side you have 1, and on the right side you have 3a and minus b. So that means 3a and minus b is equal to 1. Equate the coefficients of x square, x, or maybe the constant terms, and then find the value of capital A and b the way we just solve linear equations. So this means a is minus b, and if I put a as minus b here, so it becomes minus 3b minus b. So this is minus 4b equals 1. So the value of b is minus 1 by 4. If b is minus 1 by 4, a is going to be 1 by 4. That means my entire integrand can be written as integral of a upon x minus 1. So a is 1 by 4, I will take 1 by 4 out. 1 upon x minus 1 plus, or let me write it inside only for now because I have b also. So b might not have the same numerator or denominator. So it is 1 upon 4 into x minus 1, and the next partial fraction is going to be minus 1 upon 4, and this is x plus 3. Entire expression into brackets and then dx. So what is the integral? Now it is easy to integrate. You can take this 1 by 4 out, and the integral of this is log of x minus 1. Here you will write minus 1 by 4, and the integral of this expression is again log of x plus 3 plus the constant of integration. So as soon as you integrate, just put the constant of integration. So this is your final answer. You can take 1 by 4 out. You can simplify it further also, but you can leave it here also. So it becomes log of x minus 1 minus log of x plus 3 plus c. This can be further simplified and written as 1 by 4 log of x minus 1 upon x plus 3 and the constant. So you can leave it here also, you can simplify and bring it here also. So it's okay, right? Now let's look at the next question. 3x minus 2 upon x plus 1 x minus 2 whole square. How do you break it into partial fractions is, you will write let. So how do you start? Let 3x minus 2 upon x plus 1 into x minus 2 whole square as a upon x plus 1 and b upon x minus 2 and c upon x minus 2 whole square. So when you have a linear factor in the denominator with a power, you have to use this breakup for the partial fraction. So just go through the handout for how to break up any function into partial fractions. So these are the partial fractions. Again, the next step is going to be you equate the coefficients of x square, x and the constant term. So let's do that. That means 3x minus 2, the numerator of the left side is equal to a into, because it has x plus 1 already there, so it is going to be multiplied by x minus 2 whole square plus b. X minus 2 is already there, so the left out factors are x plus 1 and x minus 2 plus c. It has x minus 2 whole square already in the denominator, so the only factor left out is x plus 1. Now you just simplify this. A minus b whole square is a square plus b square minus 2ab plus b, and if you multiply them you get x square minus x minus 2 plus cx plus c. Simplify it further, or you can skip certain steps if you are used to doing it. The intention is just to equate the coefficients of the various terms that you get here. 2b plus cx plus c, and on the left side you have 3x minus 2. Now you equate the coefficients of x square. You have ax square, bx square, but there is nothing on the left side. So that means a plus b equals 0. This also means a is equal to minus b. We'll use it further. Coefficient of x is 3. So that means 3 is equal to, what are the coefficients of x? Minus 4a, coefficient of x, minus b plus c. And now if I replace a by minus b, this becomes equal to 4b minus b plus c. So this is equal to 3b plus c. Next equation, if I equate the constant term, minus 2 is equal to 4a minus 2b plus c. Now again I can replace a with minus b. So this becomes minus 4b minus 2b plus c. This is equal to minus 6b plus c. So you have two equations, 3b plus c equals 3 and minus 6b plus c. If you look at the coefficients, the way we solve linear equations, you just subtract the two equations. What do we get? C gets cancelled and it becomes 9b, and the left side we have 3 plus 2 becomes 5. So that means the value of b comes out to be 5 by 9. When b is 5 by 9, then that means a is going to be minus 5 by 9. Now you have the value of a and b, and you need to find the value of c. So you can use any of these equations 1 and 2. So it is 3b plus c equals 3. So you put the value of b here, 3 into 5 by 9 plus c equals c. So the value of c is 3 minus 5 by 3, 9 minus 5 is 4 by 3. So now you have the value of a, b and c. That means the question can be broken down into partial fractions. So what are the partial fractions? You have A is minus 5 by 9. So it is minus 5 by 9 and the denominator is x plus 1. What is B? B is 5 by 9 plus 5 by 9 and the denominator is x minus 2. And what is C? C is 4 by 3. So it is plus 4 by 3 and the denominator is x minus 2 whole square. Now you need to integrate this entire expression with respect to x and get your final answer. Yes, it is easy. Now the question has been reduced to a form that you can easily integrate. What is the integral of this first part of this first partial fraction? It is going to be minus 5 by 9 log of x plus 1. Yes, integral of the second term 5 by 9 log of x minus 2. Now the denominator is not a linear expression, is x, so you will not use log here. So it is going to be plus 4 by 3. What is it? X minus 2 to the power minus 2. Minus 2 plus 1 becomes minus 1. So that means it is minus 1 upon x minus 2 to the power of only 1 plus constant of integration. So the entire expression becomes minus 5 by 9 log of x plus 1 plus 5 by 9 log of x minus 2 minus 4 by 3, and in the denominator you have x minus 2 plus the constant of integration. So this becomes your final answer. Just equate the coefficients of x square, x and the constant term carefully and solve the linear equations so that you get correct values of a, b and c. Once you have the values of these three constants a, b and c, you can just put them and the question breaks up into partial fractions, and then you can integrate each of these partial fractions and get the final answer. Hope you understood? Yes? Great. So let's move to the next question. Now here the question, this one is a little tricky, I will say. Even though the numerator denominator both are in terms of linear factors, but none of them can be cancelled. So what do? We have to somehow separate them out. So let's first club them together and then see is there some other way to separate them out. The numerator will become x square minus 3x plus 2 upon x square minus 7x plus 12. Now if you look at this expression, the degree of numerator is same as degree of denominator. When it is same, when the degree is same, what do? Balancing. When the degree of numerator is greater, we do long division, but when the degree is same, we can try and do balancing. Now how is the balancing possible here? It is x square, x square. Let's look at rest of the expression. So I can write this as x square. If I want minus 7x here, that means I need minus 4x and plus 4x. So if I do plus 4x and minus 4x. Variables can be added and subtracted but not divided and multiplied. When we are doing balancing, be careful, you cannot do 1 by x and then x. But you can do minus x and plus x. So you can do here plus 4x and minus 4x so that you have minus 7x here. Again for 2 needs to be changed to 12. So I can do plus 10 and minus 10 to make it equal to 12. So this becomes plus 12, and what are the terms that are left out? Plus 4x, let me write it on the side, and I have minus 10. The denominator is x square minus 7x plus 12, and I need to integrate this with respect to x. So now I have some part of the numerator same as denominator. So now I can separate out into two fractions like this, right? So the integrand becomes equal to 1 plus 4x minus 10 upon x square minus 7x plus 12. So the intention was to break it into the proper rational form. Now it is into the proper rational form. 1 is by this side and the degree of numerator is less than the degree of denominator. How to do this now? Now we already know that the fractions, that the factors for the denominator are x minus 3 and x minus 4. So I can write the same thing as 1 plus 4x minus 10 upon x minus 3 and x minus 4. Yes, and now I can integrate using partial fractions. This expression needs to be integrated using partial fractions. So I will not do anything with this. This is the integrand. You can use capital letter I here and leave it here in this form. And now you do let 4x minus 10 upon x minus 3, x minus 4 equated to two partial fractions a upon x minus 3 plus b upon x minus 4. So if you equate the coefficients, 4x minus 10 equals a into x minus 4 plus b into x minus 3. Equate the coefficients, 4 is equal to a plus b, and the second equation is going to be minus 10 equals minus 4a minus 3b. This means a is 4 minus b. If I substitute a as 4 minus b in the second equation, I get minus 10 equals minus 4, 4 minus b minus 3b. So just simplify it and get the values. 4 minus 3 is 1, b is, so that means b is minus 10 plus 16, so the value of b comes out to be 6. Value of b is 6, so that means you can put it in this equation, equation number 1. The value of a is going to be 4 minus 6, that is minus 2. Right, so a is minus 2 and b is 6. So that means this integrand, now the entire integrand can be written as integral of 1 plus, break it into partial fractions, a is minus 2 upon x minus 3 and b upon x minus 4. Now be very careful here that you are writing a with the correct denominator, b with the correct denominator when you are putting the values of the constants back, right? The entire expression has to be in the brackets and put a dx also. Now you can integrate this easily. Integral of 1 is x, integral of this is going to be minus 2 log of x minus 3 plus, what is the value of b? It is 6. So let's write 6 here. So it is 6 log of x minus 4 plus the constant of integration. So this becomes your answer. So this is your final answer, right? Okay. Now let's come to the last type of integration, which is integration by parts. Where do we apply integration? Now in differentiation we had the product rule and the quotient rule, but here we do not have any kind of product rule. So when you have two functions being multiplied, two functions are being multiplied, then basically you need to integrate by parts. You split them into separate parts. How do you split them? Read this equation. Try to understand what is written here and how do we learn that. Speak after me. Speak along with me. Integral of two functions u and v. First function into integral of second function minus integral of derivative of first function into integral of second function. So how do we speak that? Repeat after me. First function into integral of second function minus integral of derivative of first function into integral of second function. Once more. First function into integral of second function minus integral of derivative of first function into integral of second function. It is not confusing. Trust me, it is not confusing. When we do certain questions, you will understand how to use it. Now here when you are given that the question has two functions being multiplied, how do you choose which one is the first function and which is the second function? The order is ILATE, ILATE, inverse trigonometric functions, log, algebraic, trigonometric and E. So we are going to focus on logarithmic, algebraic and exponential functions, LAE. So the function that is occurring at the top is the first function, and the one that is at the bottom is the second function. So you need to first identify which is the first function, which is the second function, and then just apply this integration by parts and you will be able to solve it. There is a special integral when we do integration by parts. If the question has e raised to power x and within the brackets you have a function and its derivative also. So the function is also there, derivative is also there, and both these are enclosed in a bracket with e raised to power x outside, then you can directly write that the integral is e raised to power x into fx. So this is a special form of integration by parts. So we will just see how to solve questions. The question is integral of x e raised to power 2x dx. Now here this is the algebraic function, this is the exponential function. That means the algebraic function comes first in this order. That means this is going to be my first function and the exponent is going to be my second function. So how do we integrate? First function into integral of second minus integral of derivative of first into integral of second. Let's see how to write it. It is not confusing, trust me. So first function as it is, first function into integral of second. Now here you make this integral sign a little smaller, integral of second, minus make this integral sign a little bigger because this has to be inside this also. Integral of derivative of first. What is derivative of x? D by dx. I am not doing it, just writing as per the pattern, as per the form for integration by parts. First function into integral of second minus integral of derivative of first into whatever was here, integral of second. Write it with the smaller integral sign so that you don't get confused. So this is what we need to do. First function into integral of second minus integral of derivative of first into integral of second as it is inside it also. That's it. Integrate this now. Now the first function is x, integral of e raised to power 2x. What is the integral of e raised to power 2x? It is going to be e raised to power 2x upon 2 because the coefficient of x is 2, so you get a 2 in the denominator also. Minus integral of, what is the derivative of x? 1. 1 into what is integral of this? We have already written e raised to power 2x upon 2 and then dx. Now here you have done integration here once. So you will get one constant. So there is no need to include multiple constants. In the end we can just put one constant when we get rid of all the integral signs. So what is the integral of this? X by 2 e raised to power 2x minus integral of this is, I take 1 by 2 out, integral of e raised to power 2x is, integral of e raised to power 2x is e raised to power 2x. Yes. So that means e raised to power 2x upon 2 again, plus the constant of integration. So put the constant of integration only once, that is okay. So now this entire thing becomes x by 2 e raised to power 2x minus e raised to power 2x by 4 plus c. So this is my answer. Done? Last, okay, the next question is x square into log x. If you want, pause this video, try this question on your own. See what is the first function, what is the second function, try to attempt it. If you are able to do, wonderful, otherwise let's continue. So just pause the video and give it a try if you can. So just wisely use what is the first function and the second function. So let's see how to solve it. The first function is the algebraic function x square and first function is the logarithmic function ILATE. So first function is log x and the second function is x square. Right? So the rule is first function into integral of second function. Make this integral sign smaller, you will not get confused. Minus bigger integral sign. Integral of derivative of the first function. So I am just writing d by dx of log x, not writing the derivative directly, into integral of second function. So whatever you have written here, write it again here. Integral of x square dx and the entire thing into bracket and put a dx. Now what is log x, and then the integral of x square is x cube by 3 minus integral of derivative of log x is 1 by x, integral of x square is x cube by 3 and then you need to integrate it again. So this becomes x cube by 3 log x minus integral of x square dx, and let me get this 1 by 3 out. So this becomes x cube by 3 log x minus 1 by 3 integral of x square is x cube by 3 plus the constant of integration. So my final answer is going to be x cube by 3 log x minus x cube by 9 plus c. Fine? Fine? So this is my final answer. If you want, you can take x cube by 3 common out and then simplify it further also, but you can leave it here also. Perfectly correct, right? Now the last question, e raised to power 3x, and in the brackets we have log of 3x plus 1 by 3x. Can you identify the pattern? Can you identify the special integral that we need to use? There is e raised to power x outside and there is a function inside, and you have the derivative of the function also inside. So that means you can directly write your answer. What is the formula? E raised to power x, and if you have a function and its derivative being added inside the bracket. So we just write this as equal to, it is as good as e raised to power x fx plus c. That's it. Your work is done. So that means in this question, what is fx? Fx is here, derivative is here 1 by 3x, and outside you have e raised to power x. So just be careful, this 3x and this 3x, they are all same, right? So that means my answer is going to be e raised to power 3x into fx. What is fx? Log of 3x plus c. This is my answer. That's it. Easy? Right? So I hope you got the hang of indefinite integrals. What are the different ways of doing indefinite integrals? First thing that we did was, we just had a look at what are the primitive formula for doing integration. So we just started with the basic formula for integration, and then we looked at different ways of integrating. The first one was by substitution, then partial fractions, and then by parts. So first thing is, remember all the basic formula. Apply them for rational expressions. For rational expressions, again there were different techniques. You have to make the numerator, degree of numerator less than degree of denominator, and then integrate. Again, then you have to use either substitution or partial fractions or by parts. So once you have simplified the rational expression into a proper rational expression, you can use it integration by parts. You can use integration by parts to integrate it further, and if you just have constants in the numerator, then you can just use log. So I hope all the ways of doing indefinite integrals are clear to you. This is the basis for doing definite integrals and applications of integrals. So just practice a few more questions if you want. The questions here that we have covered in this video, some of the questions are from the CBSE handbook and some questions are from ML Agarwal. So I have already covered some questions from both the books, whichever was important, whatever was important to make you understand the concepts of indefinite integrals. Go through it again if you need, and then start with definite integrals and applications of integrals. So if you like the video, please don't forget to like it, share it with your friends who are struggling with the basics of integration, share it with your friends, subscribe to Boundless Maths, keep learning, keep growing. Thank you.